Hello everyone, let's talk more about slopes. First of all, we are going to see the relationship between the slopes and parallel lines. If we take non-vertical parallel lines, the slope of those lines are equal and they have different y-intercepts. If it is given that the slopes of two lines are equal, that means they are parallel. And also, if two distinct vertical lines have undefined slopes, this also implies they are parallel. Here we are going to write an equation of the line passing through the point -2, 5 and parallel to the line whose equation is y equals 3x plus 1. We know that if two lines are parallel, they have the same slope. Then by using this equation, we can find the slope of parallel line. So it is given that y is equal to 3x plus 1, and by using this equation we can find the slope of this line. We know that the slope is equal to 3, and this implies a parallel line will have slope of 3. Now we know the slope of parallel line, and also we know one point on that line, that is -2, 5. Then by using point slope form, we can define the equation of the parallel line. We know the equation of the parallel line in point slope form is y minus y1 is equal m times x minus x1. In this case, x1 equals -2 and y1 equals 5. So the equation becomes y minus 5 is equal 3 times x plus 2. Now this is an exercise for you. You need to write an equation of the line passing through the point 2, 5 and parallel to the line whose equation is y equal 2x minus 1. To find the equation of a parallel line, you can use the previous method. By using this equation, you can find the slope of the parallel line, and also we have one point on that line. By using those information, we can write the equation of that parallel line. Now here we are going to talk about the relationship between the slopes and perpendicular lines. Perpendicular slopes are negative reciprocals of each other. That means if we take the product of the slopes of two perpendicular lines, the result is always equal to -1. In addition, if we have a horizontal line and we know that the slope of that line is 0, and that is always perpendicular to a vertical line with undefined slope. Now we'll see one example. We need to find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 equals 0. We know that if two lines are perpendicular, the product of those slopes equals -1. Then by using this equation, we can find the slope of this line. We need to solve this one for y. After solving this one for y, we will have y is equal -1/3 times x plus 4. This implies the slope of this line is -1/3. So the slope of any line perpendicular to this line is 3, because if we multiply 3 and negative 1 over 3, the result will be negative 1. And also here we are going to define the slope as rate of change. We know that we define the slope as the ratio of the change of y coordinates and the change of x coordinates. That defines how fast y is changing with respect to x. For any linear function, we can define the slope as the rate of change of the dependent variable per unit change in the independent variable. In 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. We are going to use this information to find the slope of the linear function representing adult men living alone in the United States. By using this information, we can define two ordered pairs. Here we can see 1990 is related with 9 million adults, and also 2008 is related with 14.7 million adults. So here we have two ordered pairs of a linear function. We know that if we have two ordered pairs related with a linear function or 2 points on a line, we can define the slope of that line. Now we know that that's equal to change of y coordinates over change of x coordinates. Now the change of y coordinates, the difference between these two values, and the change of x coordinates, the difference between these two values. So the slope will be 0.32. And finally we can define the rate of change is 0.32 million men per year. And here we are going to define the average rate of change of a function. If we have 2 points on a line, x1 f of x1, x2 f of x2, here f of x1 implies the value of y1 and f of x2 implies the value of y2. By using these 2 points, we can define the average rate of change of f from x1 to x2 is f of x2 minus f of x1 over x2 minus x1. And here we are going to find the average rate of change for fx. F of x is equal x cubed from x1 equals negative 2 to x2 equals 0. Now we know that average rate of change is f of x2 minus f of x1 over x2 minus x1. Now here we know that the value of x1 is negative 2, value of x2 is 0, and also we need to calculate the value of f of 0 and f of negative 2. Since f of x is equal x cubed, f of 0 is equal 0 cube, and f of negative 2 is equal negative 2 cube over 0 minus negative 2. And as the result, we will have 8 over 2 that equals to 4. That is the average rate of change for f of x equals x cubed from x1 to x2. Thank you.